In this video, I will show you how to find missing sides and angles of a right triangle using sine, cosine, and tangent. First, you have to be able to identify which sides are opposite, adjacent, and hypotenuse of the right triangle. The hypotenuse is first. It is always across from the 90-degree angle. For opposite and adjacent, it depends on what angle you're talking about. So focus on one angle. The opposite side will be the side across from the angle, and the adjacent side will be the side that's closer to the angle. Now, with that in mind, sine of the angle is opposite over hypotenuse, cosine of an angle is adjacent over hypotenuse, and the tangent of an angle is opposite over adjacent. These definitions are summarized by the word SOHCAHTOA, where SOH stands for sine is opposite over hypotenuse, CAH is cosine is adjacent over hypotenuse, and the TOA part reminds us that tangent is opposite over adjacent. So pretty much every time we do a problem, I'm going to start by writing down the word SOHCAHTOA as a reference. So if you can spell SOHCAHTOA properly, you are golden. So we're supposed to find the tangent of M. Let's start by labeling the sides. Start with the hypotenuse, which is across from the 90-degree angle. So that means this is the hypotenuse. Now, circle the angle that you're dealing with, which is angle M, and draw an arrow going away from it, and then that will be the opposite side. The other side is the adjacent side. So now, we're supposed to find tangent, so we're definitely going to write tangent down. But tangent is opposite over adjacent. So that's going to be 84 over 13. All right, moving on to problem number 2. All right, so let's go ahead and write SOHCAHTOA again. And let's label the sides. Where's the hypotenuse? Well, it's across from the 90-degree angle, so that makes this the hypotenuse. Now, this time we're dealing with angle F. So let's circle angle F and draw an arrow going away from it, and that will be pointing at the opposite side. That means the 18 is the adjacent side. Now, we're supposed to be finding cosine, so let's write cosine of F equals, but cosine is adjacent over hypotenuse, so that will be 18 over 82. All right, we need to reduce these fractions. Okay, so half of 18 is 9, and half of 82 is 41. Okay, problem number 3. So again, let's write SOHCAHTOA. Where is the hypotenuse? It's always across from the 90-degree angle, so that makes this the hypotenuse. Now, we are dealing with angle K, so we have to circle that angle, draw an arrow, and that's going to be pointing right at the opposite side. That means the 24 must be adjacent. Now, for this problem, we're supposed to be finding the sine of K, so let's write that down. Sine is opposite over hypotenuse, so that will be 7 over 25. All right, number 4. Write down SOHCAHTOA for easy reference. Where is the hypotenuse this time? It is 82. The hypotenuse is across from the 90-degree angle. This time we're dealing with angle P. So circle angle P, draw your arrow. That's going to indicate the opposite side. The other side will be adjacent. For this problem, we're supposed to be finding the cosine of P. Cosine is adjacent over hypotenuse. So that will be 80 over 82. All right, now we have to reduce this down. So half of 80 is 40, and half of 82 is 41. Okay, switching gears a little bit here. We're going to use the fact that the angles in a triangle add up to 180 to find the unknown angle measure. So look, these first two angles are 90 and 63. So look, what I'm about to do right now is sort of the long way. Since they all add up to 180, I can start with 180, subtract 90, and then subtract 63. Okay, so that is 27. All right, so the missing angle is going to be 27 degrees. Now, slightly quicker, because we have a right triangle, we're always going to have 90 degrees right here. So that means the other two angles have to add up to 90 degrees for a total of 180. So it's slightly quicker. Rather than dealing with 180, you can find the missing angle by subtracting the one angle from 90. So it would be slightly quicker to simply do 90 minus 63 instead of doing 180 minus 90 minus 63. So notice if I do 90 minus 63, I'm going to get the same answer. So next time, let's just do this. All right, problem number 6. It's going to jump on me every time I change colors. Okay, so let's use our shortcut. So this time we're just going to do 90 minus 22. So of course that is 68. All right, how about number 7? Okay, they're letting us know we're going to be using the Pythagorean Theorem for this problem, but we should have known that anyway, right? Because anytime you have two sides and you're looking for the third side, that's going to be the Pythagorean Theorem. So a squared plus b squared equals c squared. Make sure that the c part is the hypotenuse. So we have to do 84 squared plus 32 squared equals x squared. Make sure that the one that's by itself is always the hypotenuse. All right, and then we'll add these together, of course. $80, interesting. Now, to get x by itself, we need to take the square root of both sides. All right, so that's 89.889 because we got to round up. So that's it for number 7. So if I want to find this missing side right here, Pythagorean theorem. So remember that the hypotenuse has to be by itself. So this will be 10 squared plus x squared is equal to 26 squared. So this is going to be 100 plus x squared is equal to 676. Subtracting 100 from both sides gives us x squared is equal to 576. And that's 24. So I just took the square root of both sides right there. Okay, to get x by itself. So the final answer is 24. So this time I want to find this one. This is the hypotenuse, so this will be by itself. So 21 squared plus 12 squared is equal to x squared. So let's see, 21 squared is 441. 12 squared is 144. That's equal to x squared. So this is going to be 585 is equal to x squared. And then we take the square root of both sides, and that should be the answer. All right, so 24.187. All right, so one more of these little guys. So I'm looking for this x right here. So the hypotenuse is the 18. So we'll make sure that that ends up by itself. So we will have x squared plus 7 squared is equal to 18 squared. So that's going to be x squared plus 49 is equal to, let's see, 18 squared is 324. So subtracting 49 from both sides, so I will have x squared equals 275. And then you take the square root of both sides. So that's going to be 16.583. Okay, so now back to sine, cosine, and tangent. So let's start by writing SOHCAHTOA. Which side is the hypotenuse? The hypotenuse is across from the 90-degree angle, so this will be the hypotenuse right here. Next, circle the angle that you're dealing with and draw an arrow going away from it. This will be the opposite side. The other side is the adjacent side. Now, which two sides are we dealing with? The x is opposite and the 62 is adjacent. So which trig function involves opposite and adjacent? That is going to be tangent. Tangent is opposite over adjacent. So let's go ahead and write down tangent. Tangent of the angle. So next you put the angle that you are given. opposite over adjacent, that's going to be x over 62. Now, when the variable is in the top, this is when you multiply. So we will multiply both sides by 62. So these will cancel each other out. And that will give us the answer. We're just going to put this in the calculator. 62 tangent 28. $32.966. Got to round up. 32.966. Okay. So, TOA. Where's the hypotenuse? The hypotenuse is across from the 90-degree angle, so this is the hypotenuse. Now circle the angle that you're dealing with, draw an arrow going away from it, and then that'll be the opposite side. That means the other side up here is adjacent. But which two sides are we going to actually use? We're going to use the 28 and the 62. That's opposite and hypotenuse. Well, which trig function involves opposite and hypotenuse? That's the sine function, because sine is opposite over hypotenuse. So let's start by writing down sine. Sine of the angle. Even though it is a variable, you go ahead and put sine and you put the angle next. Now, opposite over hypotenuse, that's 28 over 62. When the variable is inside the trig function, this is when we do the inverse. So we're going to do, instead of sine, we will write sine inverse. And these two will kind of trade places. So we will have inverse sine of 28 over 62 is equal to x. And this just goes in the calculator. So inverse sine of 28 over 62. So that's 26.847. Okay, how about number 13? Well, wait a minute. This problem is going to be different. Notice we have neither of the acute angles are present. On the last two problems we did, we had 28 degrees to work with. And on number 12, we had x degrees. Even though it was a variable, it was an angle. Okay, but on number 13, we have no angles. So you have to recognize that this is actually a Pythagorean theorem problem. When it's all sides and no angles, that's Pythagorean theorem. So we'll do what we were doing a minute ago. And we'll do a squared plus b squared equals c squared. Just remember to always put the hypotenuse by itself. So this will be 28 squared plus 62 squared is equal to x squared. All right, so that's 784. 3,844. Okay, add these together. 4,628. and then you take the square root of both sides. $68.029. All right, and that was the answer number 13. So let's see what's up with number 14. Notice now we have an angle again. So as soon as I see the angle, I know we're back to SOHCAHTOA. Okay, unless we're just being asked to find the other angle. So where's the hypotenuse? The hypotenuse is across from the 90-degree angle, so this is the hypotenuse. Next, circle the angle that you are given and draw an arrow going away from it, and that will indicate the opposite side. The remaining side is adjacent. So, which two sides are we actually dealing with? Well, 62 is adjacent, x is the hypotenuse. Which trig function involves adjacent and hypotenuse? That's going to be cosine. So we will write cosine of 28. Adjacent over hypotenuse, that's 62 over x. When the variable is in the denominator, this is when you swap. So we're going to have x equals 62 over the cosine of 28. And then you can just put this in your calculator. Okay, 62 over the cosine of 28. So that's 70.219. Okay, so that was number 14. All right, I see the 28 degrees. This is going to be another SOHCAHTOA problem. Where's the hypotenuse? It's across from the 90-degree angle, so this will be the hypotenuse. Next, circle the angle that you are dealing with and draw an arrow. This will be the opposite side. The other side is adjacent. Now, which two sides are we actually dealing with? Opposite and hypotenuse, the 62 and the x. Which trig function involves opposite and hypotenuse? That's going to be the sine function. So we will write sine of the angle is equal to opposite over hypotenuse, 62 over x. Now, when the variable is in the denominator, that's when you swap. So we will have x equals 62 over sine 28. And this is just a calculator situation. So 62 over sine 28. That's 132.063. So that is the answer to number 15. Now, is this a SOHCAHTOA problem? No. Notice that we have none of the angles, and we're not looking for either of the angles. Instead, it's all sides. We're given two sides and we're missing one side. That is when you do the Pythagorean theorem. So a squared plus b squared equals c squared. Make sure your hypotenuse is by itself. So this will be 28 squared plus x squared is equal to 62 squared. $784 plus x squared $3,844. All right, now you subtract 784 from both sides. So that's 3,060. And then you take the square root of both sides. $55.317. All right, so that's it for number 16. Okay, so number 17 is definitely a SOHCAHTOA problem. All right, I see the angle that we're given here, and that's what we're going to wind up using. So, which side is the hypotenuse? We always start with that. So the 85 is the hypotenuse because it's across from the 90-degree angle. Now, circle the angle that you're given, draw an arrow. That will be the opposite side. The other side must be the adjacent side. Which two sides are we actually dealing with? The 85 and the x, that's opposite and hypotenuse. Which trig function involves opposite and hypotenuse? That is the sine function. So we will write sine of the angle is equal to opposite over hypotenuse, so x over 85. When the variable is in the top, the numerator, that's when you multiply both sides by the denominator. That way, these will cancel each other out. And that leads us straight to the final answer, because x is now by itself. So 85 sine 52 in the calculator. So that's 66.981. Because we had to round up. So that's it for number 17. Number 18, SOHCAHTOA all the way. All right, where's the hypotenuse? It's across from the 90-degree angle, so this is the hypotenuse. Circle the angle that you are given. Draw an arrow. That'll be the opposite side. That means this side over here must be adjacent. Now, which two sides are we actually dealing with? The x and the 15. That's opposite and adjacent. Which trig function involves opposite and adjacent? That's the tangent function. So we will write tangent of the angle is equal to opposite over adjacent, so 15 over x. Guys, when the variable is in the bottom, the denominator, that is when you do a swap. So we're going to have the x over here, and then we will have 15 over tangent 34. And then this brings us to the answer. Just put this in your calculator. So 15 over tangent 34. 22.238. Okay, so that was number 18. Number 19. All right, let's keep rolling with SOHCAHTOA. Where is the hypotenuse? It's across from the 90-degree angle, so this will be the hypotenuse right here. Now, circle the angle that we're given and draw an arrow going away from it. This will tell you the opposite side. The other side is going to be the adjacent side. But which two sides are we actually dealing with? We have this 26 and the x. That's opposite and adjacent. Which trig function involves opposite and adjacent? Well, that's the tangent function. So we will write down tangent. Tangent of the angle. Don't forget the angle. All right, so tangent is opposite over adjacent. So that's x over 26. All right, is this the one where we multiply? Is this one where we swap? Or is this where we do the inverse? Well, when the variable is in the numerator, this is when you multiply. So we multiply both sides by 26. That way these cancel each other out. And that gives us the final answer, because x is now by itself. So 26 tangent 55. $37.132. Got to round up. 37.132. Okay, SOHCAHTOA again. All right, where is the hypotenuse? It is across from the 90-degree angle, so this will be the hypotenuse right here. Next, circle the angle that you're dealing with, even if it is a variable. Draw an arrow going away from the angle, so that makes this the opposite side. So that means this must be the adjacent side. So which two sides are we actually dealing with? We have the 28 and the 42. That is adjacent and hypotenuse. So which trig function involves adjacent and hypotenuse? That's going to be cosine. So we will write cosine of the angle, even though it is a variable, and that will equal adjacent over hypotenuse. So in this case, that is 28 over 42. Now, is this the one where we multiply, swap, or inverse? When the variable is inside the trig function, that is when you do the inverse. So we will have inverse cosine of 28 over 42 is equal to x. And this is just a calculator thing. Okay, so we will do inverse cosine, so second cosine of, 28 over 42. So 28 over 42. So that's 48.1. We got to round this up. So 89 rounds up to 90. So this will be 48.190. All right, and that is it for number 20. Okay, so let's start by writing SOHCAHTOA. SOHCAHTOA. Where is the hypotenuse? It is always across from the 90-degree angle, so this is the hypotenuse. Next, circle the angle that you're dealing with, even if it is a variable. That will indicate the opposite side. That means this empty side over here is the adjacent side. So, which two sides are we actually dealing with? Well, we've got the 15 and the 12. That's opposite and hypotenuse. Which trig function involves opposite and hypotenuse? That's going to be the sine function. So let's write down sine of the angle, even if it is a variable. And so sine is opposite over hypotenuse, so that is 12 over 15. Again, when the variable is inside the trig function, this is when we do the inverse. So we will do the inverse sine of 12 over 15 is equal to x. And then this is just a calculator thing. So inverse sine of 12 over 15. So that's 53.130. All right, so that is number 21. All right, one more problem. Okay, again, SOHCAHTOA. All right, where is the hypotenuse? The hypotenuse is across from the 90-degree angle, so we always start with that. So here's the hypotenuse. Then circle the angle that you're given, draw an arrow away, and that will indicate the opposite side. That means the other side over here is the adjacent side. But which two sides are we actually dealing with? The x and the 61, that's adjacent and hypotenuse. Which trig function involves adjacent and hypotenuse? That will be the cosine function. So let's go ahead and write down cosine. Cosine of the angle that you circled, and cosine is adjacent over hypotenuse, so that is x over 61. So when the variable is in the numerator, this is when you multiply. So we will multiply both sides by 61. That way these will cancel each other out. And that leads you straight to the final answer, because x is now by itself, and we can just put this in the calculator, 61 cosine 40. So that is 46.729. Got to round up. 46.729. And that is how you can find missing sides and angles using sine, cosine, and tangent. And the Pythagorean theorem thrown in as a bonus.